So this it's about the 2226 concept today, and the best practice example today is the three-story building in Austria in Lingenau. It is built according to the 2226 concept developed by Baumschlager-Eberle architects. The town in which you can see here the bird view and is located in West Austria, and it is characterized by a very traditional architecture, which also transferred to the appearance of the project in a very modern way. I would like to show you some data about the project. This one is a mixed-use building with a large with a floor area of around 2,300 square meters. 4 floors high. It was completed and occupied in 2019, and the construction costs were around 3.3 million euros. The architects are, as I mentioned before, Baumschlager-Eberle, who have around a dozen offices in Europe and Asia. I am the managing director of one of the subsidiaries called 2226. The project is located around 15 minutes from the headquarters. You can see here in red is marked Lustenau, which is in Austria, and is around 15 minutes away from the headquarters of Baumschlager-Eberle Architects. Before I talk about the 2226 concept in detail, let us talk about energy consumption of buildings. During the operating time, not while it's built and so on. These are different topics, but we don't have enough time today to talk about gray energy and all these topics. But let us just talk about the energy consumption very brief. A building, according to the standard, usually requires a high energy consumption for cooling over a long phase in summer, as you can see here in blue. The gray part of the diagram is showing the comfortable temperatures in the indoor between 20 and 26 degrees. The blue shows the energy consumption of cooling. So we need it, let's say, in Europe or in Austria from more or less end of April to end of September, usually. In winter, on the other hand, a lot of energy consumption is required for heating for a long time. It is more or less from the beginning of November to the end of March. And the comfortable temperatures inside are only achieved for a very short period of time without energy for cooling and heating. This is usually a standard, a building according to standard. In a structurally optimized building, this energy consumption can be reduced, and the period of time in which comfortable temperatures can be achieved without additional energy is extended. So you see now we just have a little range of blue and less range of red compared to the slide before. So, so what is 2226? It all started with a vision of Dietmar Eberle or Baumschlager-Eberle architects. The idea of constructing a building with no heating or mechanical air conditioning, a people-oriented structure with good air quality and comfortable indoor temperatures at all times, always within the comfort range between 20 to 26 degrees. This is also giving us, obviously, our name. In many buildings, human beings have become no more than disruptive elements with building mechanical services regulating and even limiting their behavior. Developed using the elemental means of architecture, it is a building constructed with the focus on humans. It is a concept that offers temperatures between 22 and 26 degree all year around. And there is no, as I said before, no need for active heating, active cooling, or mechanical ventilation. How does the concept 2226 work? It is based on three core aspects: the building structure, the use of daylight, and the building operating system. To explain these aspects a bit further, in the building envelope, attention is paid to an increased thermal heat capacity, also in the building structure, in the primary structure, and the facade has very low U values. All interior walls and ceilings are solid in concrete. The heat exchange between the interior and the storage mass is achieved by accessible surfaces and good conductivity of the materials. The ceiling is, in this case, for the thermal heat capacity, is more relevant than the interior or the exterior walls. The use of daylight is the second component, which is very important. The proportion of windows is optimized in relation to the floor area and opaque surface of the facade. This minimizes the use of artificial light, and also a self-shading effect is achieved in summer. A too high window wall ratio would give, so too much window area, let's say, would give bigger heat inputs in summer through the sun, solar inputs, and a bigger heat loss in winter. A too low window wall ratio would increase artificial light demand, which turns in and results in higher heat inputs, which, I mean, we would need higher heat inputs if we wouldn't have the enough solar input. The The aim of the operating system is to ensure a room temperature between 20 to 26 degree and a low CO2 concentration in the interior, so a good air quality. The regulation is sensor controlled per each room. There is a constant measurement of CO2, temperature, and humidity in every room all the time around the year. On every building there is a weather station installed on the roof, which measures the brightness of the light, the solar radiation, humidity, wind, and outside temperature. And the reaction of the operating system could be, for example, to open one of the ventilation flaps that I will show you later. And therefore it responds to the actual state in the respective room. So again, how does the concept work? If we have an empty building, one of our 2226 buildings empty, this blue line shows the exterior temperature all over the year in all three diagrams, and the green line shows how the building would react to it. So we already have a very good reaction to the green line, to the blue line, if it's the empty building, because there are many peaks going up and down in the exterior, but our interior is not responding to it too fast. It's responding very slow. So the building itself is very compact and not affected by the exterior. If there is, because of the user, there is heat input, there are computers, there is lighting, this green curve is shifting up in the second diagram. But we are already closer to our comfort range. We are not in it, but we are closer. And with the 2226 operating system, we can reach this gray part in the diagram with our green line, which shows that we can reach the comfort zone. Now some impressions of the construction of the building in Lingenau, Austria. This is the parking basement that you can see and the ground floor with the very simple brick facade and some interior walls. You can see the traditional Austrian buildings around it. The concrete slabs. And this is the almost finished building. In the basement, we have parking. In the 3 other floors, we have offices and therapy rooms, even for kids. It's a medical building. And in the top floor, in the roof floor, there are 4 apartments. These are some impressions from the finished building. The interior and the exterior. So these are just examples of the floor plans. This is one of the possible office distribution or therapy room distribution. And this is the residential use with the 4 apartments. So this is what I want to show you in detail. In the next step is one of these window details and the ventilation flaps. I just wanted to show you the facade to see the ratio of the window to wall that I talked about it before. So this is the brick that we used in the facade. It's a very simple construction, and it's a 44 to 50 centimeters brick, depending on which floor. And here is the window system where you can see that this is the interior and down is the exterior. And here's a ventilation flap which can open by the system or be opened or closed by the user. And through there is coming the natural ventilation in the building. Here is a picture of the ventilation flap I talked about. I marked it here in yellow so you can see that in the picture. Actually, you cannot see it, it's hidden. But the ventilation works perfectly fine. So to talk about the conclusion, what about the efficiency in every dimension, there is a prototype which was built in 2013 of the 2226 concept, and now it was realized 8 years before, and we have all the data, and we know that it works very well. And I want to show you very fast some impressions. These are the ventilation flaps in Lustenau. There is also the headquarters of Baumschlager-Ebel Architects. We have monitors in every room where we can see CO2, interior, exterior temperatures and everything. And I just want to tell you that it is very energy efficient. These are the data of Lustenau. The energy consumption is reduced to 1/3. The construction costs are 1/4 lower than a standard property. The building service area requires just a few square meters of space, and the life cycle costs are reduced almost 50%. If you want some more information, please visit our webpage.